In this video, we're going to talk about solving exponential equations without using logarithms. We've previously learned that we can solve exponential equations, i.e. equations in which the variable is in the exponent, by using logarithms. However, sometimes we can convert the power so that they each have like bases, and then the process is much simpler. When determining the base to use in such circumstances, usually we think small. So for instance, if we wanted to solve for x and the equation was 3x to the 3 to the exponent x minus 1 equals 9, we could simply convert each side to a base of 3. And now that we have both sides of the equation written entirely as a power of 3, we can ignore the 3's and solve the equation. X minus 1 equals 2. And therefore x equals 3. And we're done. Well, what if we have 2 to the 3x plus 4 equals 8 to the exponent 2x? Again, we can convert both the 2 and the 8 to powers of 2. So we have 2 to the exponent 3x plus 4. And instead of saying 8 to the 2x, we can say 2 to the 3 to the 2x. Well, now we're in a position where we can say 2 to the 3 to the 2x means multiply those exponents and we get 2 to the 6x. And since both sides are written as a power of 2, we can ignore the 2's and solve the equation. 3x plus 4 equals 6x, meaning 4 is equal to 3x, meaning x is equal to 4 over 3. Now, what if we had 125 to the x minus 3 equals 25 to the 4x minus 5? Well, in earlier questions, we could pick one of the sides and convert the other side's power to a power with that same base. But in this question, we actually have to reduce both of them. 125 can be thought of as 5 to the 3. So we have 5 to the 3 to the exponent x minus 3. And 25 can be thought of as 5 to the 2. So we have 5 to the 2 to the exponent 4x minus 5. Now, we have on the left and the right side a power raised to an exponent. So 3 times x minus 3 becomes 3x minus 9. And 2 times 4x minus 5 becomes 8x minus 10. So we have powers on each side raised to this with the same base. So we can ignore that base and just solve 3x minus 9 equals 8x minus 10. Adding 10 to both sides and subtracting 3x from both sides, we get 1 equals 5x, or in other words, x equals 1 over 5. Now, what if we wanted to solve this equation for x? Well, we could convert the radical to an exponent on the left side and bring the power of x up to the numerator on the right side. So on the left side, we could call the third root of 4, 4 to the exponent 1/3. And on the right side, we could say 1 over 4 to the 6x minus 7 is the same as 4 to the 6x minus 7 to the exponent negative 1. Well, on the left side, that third root of 4 was raised to the exponent negative 5, so we multiply the 1/3 and the negative 5, we get 4 to the negative 5/3. On the right-hand side, that 6x minus 7 and negative 1, they need to be multiplied, so we get 4 to the negative 6x plus 7. And so now we have a power on each side with a base of 4. So we can say negative 5/3 equals negative 6x plus 7. So add 6x to both sides, add 5/3 to both sides. We get 6x equals 7 plus 5/3. 7 is 21 over 3, so 6x ultimately equals 26 over 3. Dividing both sides by 6, we get x equals 26 over 18, and we can actually reduce that fraction to 13 over 9. Now, what if we have 7 to the exponent 5x plus 8 equals 1? Well, this is an exception to the rule. Earlier I said think small. In this case, let's make an exception. And instead of thinking small, let's turn that 1 into 7 to the exponent 0. So we can actually say that 7 to the exponent 5x plus 8 equals 7 to the 0. Each side is a power with the same base, so we can just ignore the base and say 5x plus 8 equals 0. In other words, 5x equals negative 8. In other words, x equals negative 8 over 5. Now, what if we had this equation here? It looks like a bit of a monster. Well, 9, 27, and 81 can both be expressed as powers of 3. So 9 is 3 squared, 27 is 3 cubed, and 81 is 3 to the 4. We can then multiply in each one of these cases. So 2 times 2x minus 4 is 4x minus 8. And 3 times 3x plus 2 is 9x plus 6. And 4 times 55 is 220. Now, on the left-hand side, we're multiplying powers with the same base. So we can add the exponents. We get 4x minus 8 plus 9x plus 6. Well, 4x minus 8 plus 9x plus 6 is the same as 13x minus 2. So on the left-hand side, we have 3 to the exponent 13x minus 2, and on the right-hand side, we have 3 to the exponent 220. Now, we have a power on each side, both of them with a base of 3. So we can ignore the 3's and simply say 13x minus 2 equals 220, meaning 13x equals 222, meaning x equals 222 over 13. Now, this next question here, we have 3 to the x squared minus 8x plus 16 equals 81. Well, 81 is the same as 3 to the exponent 4. So now we have each side as a power with a base of 3. We can set the exponents equal to each other. X squared minus 8x plus 16 equals 4. Subtracting 4 from both sides, we get x squared minus 8x plus 12 equals 0. That means x minus 2 times x minus 6 equals 0. So that means x minus 2 equals 0. In other words, x equals 2. Or x minus 6 equals 0. In other words, x equals 6. In this next question, this is actually pretty interesting. What we're going to do here, we're going to make 9 to the x into 3 squared to the x. And we're going to keep this 3 to the x the same. Now, we're going to see an opportunity here to create a quadratic. So instead of 3 to the 2 to the x, we're going to make it 3 to the x to the 2. Notice 3 to the 2 to the x, if you had that, 3 to the 2 to the x, we would multiply those exponents and we'd have 3 to the 2x. But if we had 3 to the x to the 2, we would multiply those exponents and we'd have 3 to the 2x. So clearly we can convert 3 to the 2 to the x to 3 to the x to the 2. Now you might be wondering, why would we do such a thing? We'll try to explain that. But we would then also have minus 90 times 3 to the x. And then this plus 750 equals 21. We'll just subtract the 21 from both sides, and we'll have plus 729 equals 0. And we're going to make that side equal 0 because we actually have a quadratic. Now, on first glance, it might not look like it, but just imagine that 3 to the x was equal to w. Then 3 to the x quantity to the 2 would be w squared. 3 to the x would be w. And we would actually have a quadratic, and we could solve by either factoring or using the quadratic formula. So that's what it says here. We have 3 to the x to the 2 minus 90 times 3 to the x plus 729 equals 0. If we let w equal 3 to the x, we have w squared minus 90w plus 729 equals 0. We can factor that, and we end up with w equaling 9 or w equaling 81. But we weren't asked to solve for w, we were asked to solve for x, so we convert back to 3 to the x. 3 to the x is either equal to 9 or 3 to the x equals 81. Well, 9 is 3 squared and 81 is 3 to the 4, so we have either 3 to the x equals 3 to the 2 or 3 to the x equals 3 to the 4, meaning x equals 2 or x equals 4.